Hello guys, welcome, good evening. This is Ashank David, and in today's live stream we are gonna continue with our C++ concepts. Sorry for the technical issue that happened in the previous stream. Just now we had another stream. We are continuing in this stream, so yeah, we will continue. So I am able to see the chats also. I am able to write the code also, a program also at the same time. So let us start. Okay, and I hope so that I am audible as well. So we are going to continue from where we left. Last time we left at data types. So if you remember data types, we left at data types. So let us start. Okay. So here we were doing I hope so that I am visible. My video got stuck, I guess. My video is stuck, I guess. Yes. Yeah, my video is stuck. Okay, so we will continue. Just a moment. Yeah. So last time we were on to data types and we were talking about different types of data types, primitive and non-primitive, as you can see. Okay. So let us continue from there. Okay, so yeah, let us continue from where we left last time. We left at data types. So if you remember, what are the different types of data types we learnt about, and the major two different categories of data types are called as primitive data types and non-primitive data types. So primitive data types were those data types which were already present into your programming language itself, which programming language understands. For example, a number type, a character or a letter type, an alphabetical type, or maybe a word type. It depends upon language to language what type of data type is understood by your language, that system. So for that reason we divide different types, and these are what you call as data types. Data type is what? The type of data that we are working into in our programming language. And in C++, we have understood that not only just in C++, but in many different languages that you will come across in future, and that will be like your C, C++, Java, Python, or basically any other language. Every time you will go ahead in any different language, you will see the concept of data types. And data types are just the type of data that you are working with. And there are two major categories, that is primitive and non-primitive, as we have already seen in our previous live. In this live, let us talk about that in depth. So we have understood that primitive are the inbuilt data types which are already understood by the system itself, and non-primitive are the user defined, which we define for our own purpose and for our own needs. So basically we define it on our own. It depends. We will talk about non-primitive data types in a more advanced concepts later on. As of now, we are going to focus only on primitive data types, and we will understand that today. Today we are going to only focus on to the types of the primitive data types, and we are going to do one more concept today, and that is the typecasting concepts, and this is going to be in our live for today. So let's start. So in primitive data type, in inbuilt data types, we have different types now. Basically we have numerical, we have decimal types, and we have other different miscellaneous types like character or boolean. So let us talk about that now. So first of all, we see short, then we see int, then we see long, then we see long. So your int short, long and long. These are the 4 data types which are the type of numerical data types basically without decimal basically. It is all integral data types, integral or integer types data types, we call them as numerical or integral data types, and these are how I have written here is these are written in a proper sequential order from the smaller to larger size. We have already understood this already in our previous live sessions that in every data type will have its own particular size as well. So, short is the smallest data type and long is the largest data type as the name suggests. Okay. So, let me just tell you about that here when you are talking about a short data type, it is the smallest of the data types in C++, and the long one is the long is the largest data type, I believe so, right. So, we are talking about this short and this is long. Basically, why we have these? Why can't we just say that we should have just one data type, say int, and that will do the job? It's not like that. Actually, the thing is that in earlier times, when systems used to be very, very basic systems were there, when RAM used to be only 512 megabytes of RAM or maybe lesser than that, or maybe in KBs when RAM used to be there, then when we created a variable, at that time it would have took a lot of memory into our RAM of our system. Let me just explain you this what I am speaking here. We are talking about variables. We have already talked about variables last time, and just giving you a brief introduction about variables also, that whenever we create any type of we want to create any type of memory location, we create variables, and this is where we understand variable concept. And to create variables, first we need to understand data types, and that is what we are learning right now. So, when a data type is created, memory is allocated for something to get stored inside it, so that I can store some data inside it. Okay, that is one thing. When these variables will get created, okay, when these variables will get created, it will take some space into our RAM storage, in our random access memory storage of our system, of our computer systems. And the problem with the older computers at the older time, because this language is a very old language, 1982 basically, and in 1982, computers at that time would have very less storage in terms of RAMs and ROMs. And when it comes to RAM, basically very less storage means you have very less space to work with. In those kind of scenarios, we had to go with a smaller data type rather than going with a larger data type. What I mean to say is, let's say if you have, let's say 500, let's say 12 KBs of RAM maybe. Just imagine 512 KBs of RAM you have, kilobytes of RAM you have. Now the thing is that the short is of 2 bytes, okay, while long is for 8 bytes. Now if you are working with this variable long, and if you are taking, let's say you have created let's say 100 variables of long type, then it would already take 800 bytes of space from this 512 kilobytes, which would be a lot in terms of a computer system, because you already took around 40 to 50% of space just by writing one program of that particular RAM. And for this reason only, we had to develop a smaller data type, short. And this is the reason why our data types is actually divided into smaller, larger and smaller and larger, like that. And for this reason, we have a lot of different varieties of, in terms of sizes, we have different varieties of this, right. So this is like that. So this is why we had to do it. Now let us understand. I hope so that you have understood the reason behind why we had a lot of different sizes in terms of data types also. So short is the basically the smallest one. Then comes your int type. Now int is something which can hold a lot of values by default, and you will be holding int, you will be like using int most of the time in most of the cases. In rare cases you will be using long in the beginning. In terms of later on development of a software, or maybe at something else in some advanced concept, you might be using long, not right now, but maybe later on in advanced concepts. But as of now, most of the job will be done by your integer type only. So int is a little bit bigger than short. So then comes your long, just long, and then comes your at last long. All of these data types that you see here, all of these data types that you see here, all of these are all your integral data types. Integral data types, meaning what? These are just numbers, basically numbers, okay, to work with, basic numbers. In a nutshell, if I want to explain you, if you don't care about the sizes, if in a nutshell you want to understand, short is the smallest number, int is a little bit larger number, long is much more larger than int, and long is the largest number of all of them. It is like that, it is so simple. You understood my point? So if you want to store a small number, you can go with the short type of data type. If you want a moderately large enough number, then you can go with integer or long type. And if you are really working with a bigger number, for example 8 digit, 9 digit number, or maybe 10 digit number, you can go with long data type. I believe it is understood by all of you. I hope so, right? So this is the reason why we are using different sizes in terms of data types. Okay. So this is about the different data types. Okay. So now this is understood. This is integral data type. So if you want to create a, now come a little bit on to variables concept. Okay. Now let us understand a little bit of variables concept also at the same time. When we are talking about variable, what exactly is a variable? A variable is a, I'll write it here, a variable is a named memory location. Variable is a named memory location. It is just a name given to a particular memory location. When you create a variable into a program, a space is reserved. And where the space is reserved, as I just now told you, RAM, random access memory, is the place where your memory gets reserved. Okay. So maybe this is your RAM. Let's talk about it. This is, let's say, your RAM. Okay. Now in this RAM, your random access memory. Okay. What is random access memory? In a nutshell, for those people who don't know what is random access memory, RAM is just a workspace in a nutshell for a computer system. Basically all your tasks, whatever is done here, is being done inside RAM. For example, I have opened Microsoft Whiteboard, this software. This software first have come into my RAM of my system. It got opened up there. So basically it is like your table where you keep your things and start working. If you don't have a table, you can't keep anything right there and you can't work with them. As simple as that. Similarly, RAM is just like that table. So RAM is random access memory, and this is the place where we can just keep our things and start working with it. So when you are creating a variable is just a memory location inside your RAM storage. Understood? Memory location inside your RAM of your device, of your system. I hope so that this is very much clear. Why we want to do that? Basically it is a memory location. Memory location means we are trying to store something inside it. That is why we are creating this memory location. It is an empty memory location. When you create a variable, you have to define what type of data you are going to hold inside it, and for this reason we are learning data types. Okay. So, in this case, these data types which I was explaining you till now are now going to be used in the concept of variables. That is why I took them first. I took data type concept first, and I am going to combine data types with variable in order to finally create a variable. It is a named memory location. The thing with C programming and C++ programming is that it uses a compiler as a translator. If you have attended our very first live sessions, you would have understood what is the difference between an interpreter and an compiler. If you have not watched that yet, please you can go ahead and watch that also. The link is already there, and there is one whole, if you go into our live section of our Coders Arcade channel, you will get that first live from C++ session, where I have explained you all about the differences between C compilers and interpreters. Basically compilers and interpreters, not C compilers and interpreters, interpreters and compilers, the difference. And I have explained you how a programming language works, what exactly it is. Everything in depth is given there. Okay. So, basically now variable is just a memory location which gets created into your RAM of your system. Why? Why we need this memory location? Basically to store. Why? To store our data. Store data. And what kind of data? That is decided by its data type. So, whenever we are creating a variable, we write this. Let's talk about syntax now. Okay, let's talk about the syntax for it. You will get it now. The syntax of writing a variable. First, you write its data type, and then you write its name, or you can say identifier. In terms of programming language, it is identifier, but in this case I am calling it as name. So, first you write its data type and then you write the name. Name of what? Name of a variable. So, in this case, let us say I want to store, I want to create a program where I am adding two numbers. I want to write a program where I am adding two numbers. Okay. So, to add those two numbers, it is not that so easy for a computer to do that. What I mean to say is to explain it to the computer. First, I need to tell my computer that I need to first take one number and then another number, and then I am going to fuse it in order to get my result. The thing here is that you need to store that first number somewhere and you need to store that second number somewhere. If you are able to figure out this, then you will be able to tell the computer to add those two numbers. But the question is, how will I store? Where do I store these two numbers? And this is the reason why we have the concept of variables. Variable is a name given to a memory location which has only one main purpose, and that is to store the data inside it. So, basically my first number will get stored into a variable and my second number is also going to get stored into my variable, and then we are going to add both of them together. Understood? So, if I have told you that this is how we are going to create our variables, you see, first we write our data type and then we write the name of the data type, name of the variable. So, here I created a data variable. Let us say I am using int. First I wrote int and then I wrote the name of the variable, let us say a. Int a I have written. So, data type is this int and name is this a. Okay. So, this int is telling me that a is the name of a memory location who can only store integer type of data inside it. Understood? I can only store integer because its data type is now defined it as int, and int is what? It is a type of a data type. Just now we have seen that here. Right here, if I zoom in here, you see we were talking about short, int, long. I am talking about this int now, right here, this int. Okay. So, first you wrote the int data type and then you wrote the name of the variable. In this case, what happens? The name of the variable is given to the name of the memory location, and we have mentioned it that it can only hold integer type. That means now integer also has a size. How much size? Integer will have 4 bytes of space. Okay, this integer will have 4 bytes of size. The size of that integer variable is 4 bytes. Meaning what? Now, in my RAM, let's come back here. In my RAM, when I wrote this int a in my RAM, here this box got created. Okay, this space, this memory location got created. And what is the size of this memory location? The size of this memory location is 4 bytes, as I told you. How I know this 4 bytes? Because it is of integer type, and integer is of 4 bytes. Understood my point? So in this case, 4 bytes of space, basically 4 bytes of space is allocated into my RAM of my system, and the name is given as, and the name of this variable is given as a. This is that variable. Understood my point? And because RAM is of a particular capacity, maybe it is 2 GB, it is 4 GB, it is 8 GB, it is 16 GB. Nowadays you have 32 GBs and 64 GBs also. You have 128 GB RAMs also. You got my point? So now the thing is different because we have moved into a technology and we are moving into a modern world. So we have a lot of space. But in earlier times, when computers were new thing, very new, RAMs used to be very less because we did not have the technology. So you used to had very less RAM, and due to that less RAM, if I am using a long or an int variable, it would take a lot of space into that RAM, of course taking 40 to 50% of the space, as I just explained you. So for that reason, we had to define a smaller data type which allows you to store a smaller number and use less space. So no space is also wasted, and the number is also, or the data is also saved into that. Well, I hope so that this concept is very much clear now. This is how variables work. Okay, so variable is just the name given to a memory location which has only one sole purpose, and that is to store the data so that we can later on work with that data. Well, I hope so that it is very much clear to all of you. Correct? Now let us move on to another data type. I believe variable concept is clear, and in this case we have understood the difference between short int, long and long. Now let us come to float. Float, double and long double are the three categories where you will see that these are of again numbers but decimal type. These are decimal numbers, point values. Okay, integer numbers you already understood, that is short, int, long and long. Similarly, we have float, double and long double. These are the decimal types, and in these also we have sizes. The smallest decimal type number is float, then we have double, and then we have long double. Only these three exists. So float can hold only up to 2 to 3 decimal values, or max to max 5 decimal values. Double can hold up to 7 to 8 decimal values, and long double can hold more than 15. The concept goes like this. In a nutshell, if I wanted to explain you. Again the same thing, size comes here. Sorry. Again the size comes here. So basically here, if you want to hold a smaller decimal number, go ahead with float. If you have a little bit bigger than that float number, go with double. And if you want more decimal values to come into place, then you go with long double. I believe it is very much clear to all of you, right? Same funda applies here also. When you are creating a variable of type float, what you can do is, you can just say float b. Okay, float b, and now we have created another variable b which can only hold a decimal type of value. Now, by the way, I am explaining you about the variable and data type concept together. One thing that when you just say, int a, and if you give a semicolon here, then what happens is, or float b with just a semicolon here, then what happens is that this is what you call as declaration, variable declaration. That means you have defined a variable, you have declared a variable, but you have not given any value inside it. So the variable is empty right now, but it can only hold an integer type of value. That is it. You got my point? Right now it is just declared, so it is called as variable declaration. Variable is declared. Let us say now I have written, rather than just semicolon, I have written int a equals to 10. I have used equals and then I have said 10. That means that this 10 went inside this int a. You got my point? This is what you call as variable initialization. Okay. Initialization happens when you put a value into that variable. You are getting my point? So this is declaration, while this is initialization. This is the difference between a variable declaration and initialization. So when a variable is just declared, none of the value is given, then it is just called declaration. But when variable's value is also given at the same time, it is now initialized. So variable is initialized. So variable initialization. Understood this very well? Great. So now if I want to initialize this variable, 1 minute, just a minute. Let's say this variable is initialized. Now I want to initialize our float b. I can just say equals to, and I can say 10. Now I cannot just say 10 because it is of float type. It can only hold float values, not an integer value. 10 is an integer value. So I need to give point anything, 25 maybe. And this is how you store a float value. This is a float value while this is an integer value. I believe it is understood to all of you. Is that clear to everyone? I believe so, right? This is very easy now. This is the difference between float and integer. Let's talk about another type. We have char. Okay. Char is character. This is not a number now. It is a character. Problem here is that a computer cannot understand a English or English word or a letter. If you want to create a variable of char, you say char, you mention char, and then you say, let's say, because I have taken a, b, I am taking c, character c in this case, char c, and in this case equals to, I have said, let us say, see the thing is, now if you are using char data type, you can only hold one single word inside, one single letter or alphabet inside, not word, letter or alphabet in this case of English. Say you have said A, but the problem is that this A cannot be understood by the system. So we always give it inside single quotes and then of course semicolon. See, just like how you have given 10 here without single quotes or double quotes here also. See, numbers are easily understood, but characters or letters would not be understood or alphabets would not be understood. So always you should give them in single quotes. I hope so that it is very much clear. You got it, guys? Yep. So this is how. Let us say you want to store a word, then what you do? You say string. Now you may say, what the hell is this string that you have written? So I say string s. S is the name of the variable. I can say here Coders Arcade. I can say here Coders Arcade. Okay, I can say here Coders Arcade like this. But again, this is a word, and word can only be held inside double quotes. Okay, so this is the difference. Char is one single letter or alphabet in English, while a string is a whole word in English. So if you want to hold a whole word, you use string data type. If you want to hold only a character, you say char data type. You got it? This is how it is done. The difference here is, when you are writing character, your character or an alphabet or a letter should be written in single quotes. While if you are writing a word, you have to write words in double quotes. This is the difference. Okay. But you might say that there is no string concept that you told us before. So yes, I did not tell you about the string data type. Let me just tell you here, string is a data type which comes under non-primitive data type. Strings. See, string is a data type which comes under non-primitive data type, but in C++ programming you can use it as a normal variable. More on this later. As of for now, you don't have to go into so much of depth, because more and more it will get confused. Okay. So make sure, curiosity kills the cat. Right now we don't have to worry about that much. I will explain, you will get to know about this slowly when we will talk about that later on. But as of now, you have understood the usage of this, right? Integer type of variable, float type of variable, character type of variable, string type of variable, and the type of data that goes inside it, right? Right? One more data type I would like to discuss. It depends. Here true or false will not come into double quotes or single quotes, even though it is a string type of value, because true or false in itself is a type of a data recognized by C programming or C++ programming in this case. I hope so that this is very much clear to all of you, right? This is how it is done, and these are the major data types that you are going to work with in C++. Integer, float, character, string, boolean. And if you want to go into more depth, you can go with short int, long int, long int, float, double, long double, character, string, boolean, all of that you can go ahead with and work around with. Well, I hope so that this is very much clear to all of you. Any doubts, you can ask me. Well, let us keep this stream for today, for this much only for today. Let us continue in the next stream. I have explained you about the data types. I have explained you about how the variables concept works, what type of values that we hold inside it, and what kind of things that we work around with when it comes to handling with the datas, different types of data types basically. Let us talk about that all in much more depth in the next stream. Well, I hope so that this is very much clear to all of you. This is enough for today's stream, I guess. And let us see. I cannot see any comments here. Okay. Yeah. So there are no comments in this stream. I believe that it is understood by all of you, right? So that's it from my side. Thank you guys for watching this stream, our YouTube live. I hope so that today's concept is very much understood by all of you. Data types and the variables concept in depth I have talked about. Every stream I will talk about one concept like this. In the next stream, in today's stream, I was not able to cover data type, typecasting, conversion type. Later on in the next stream, I'm gonna definitely cover that. I will see you next in the next coming Saturday, the next week coming Saturday. We will update this before time, and yeah, that's all for this stream, guys. Thank you for watching. This is Ashank David signing off. If you have any doubts, you can ask me, but there are no messages in the live stream comments right now, so I believe that you don't have any doubts. If you want to go with the previous videos, they are already there in the live section of our YouTube channel, so you can go ahead and watch that also. And that's all for this live stream, guys. Thank you for watching. This is Ashank David signing off. I'll see you in the next one. Thank you.